Okay, you're welcome to this class. Here we're going to be looking at simple harmonic motion that you can simply call SHM. SHM. Okay, simple harmonic motion. Now, simple harmonic motion is defined as a periodic motion. Is a periodic motion. Okay, you can use the word to and fro motion or oscillatory motion, in which its acceleration is always towards a fixed point. So please note that definition. The acceleration is towards a fixed point and it is proportional to the distance from that point. Now, examples of simple harmonic motions you have swinging pendulum, you have motion in a spring, you have swing, jangolova. We have loaded test tube in water. Okay, we have car shock absorber, that's also a simple harmonic motion. We have cradle. Okay, now here we look at simple equation of a simple harmonic motion. The simple equation of a simple harmonic motion is given as y equal to a sine omega t. Please remember that any motion that is periodic, that moves periodic with time, always has that formula. So in this case, the other kind of motion, like wave motion, has this formula. AC circuit has this formula because they move periodically with time. Now, y here is the displacement. A there means amplitude. Amplitude means maximum displacement. Okay, then omega is the angular frequency or angular velocity. Then t is the time. Now, but from there we can find v. V is the y, rate of change of displacement with respect to time. That is here, the y over the t, which is a omega cos. If you differentiate a sine omega t, for those of you that don't understand differentiation, you get a omega cos omega t. Okay, now if we combine the two equations together, this is equation 1 and this is equation 2, you are going to have this. Your v is equal to omega root a squared minus y squared, which is the velocity of a simple harmonic motion. Omega root a squared minus y squared, don't forget that. Now, but I want you to also note that at maximum velocity, y is equal to 0. That's when the velocity is maximum, y is equal to 0. Okay, so if you substitute y to be 0, you see that your Vmax is equal to omega root a squared minus 0 squared, which is omega root a squared, which is equal to omega a. So whenever you're asked to find maximum velocity, it is simply omega a. Okay, so that leads us to the acceleration of a simple harmonic motion. Acceleration, you get acceleration by differentiating the velocity, which will give us minus a omega squared sine omega t. Now, since y is a sine omega t from previous, then a will be equal to minus omega squared y. So that's the formula for acceleration. Now, but at maximum acceleration, y displacement is equal to a. So that means a maximum. Actually, this should be a maximum. The maximum acceleration now is going to be minus omega squared times amplitude. Please let us remember that. So in summary, look at the formulas there. We have v to be equal to omega root a squared minus y squared. Then we have v max, maximum speed, to be omega a. Acceleration is minus omega squared y. Maximum acceleration is minus omega squared a. Please, the last one is maximum acceleration. Correct that, please. Now, we see a question here. It says a body moving in a simple harmonic motion in a straight line has velocity v to an acceleration a with instantaneous displacement x in centimeters. From the maximum position is given by x equal to 2.5 sine 0.4 pi t, where t is in seconds. Determine the magnitude of the maximum a velocity I acceleration. Okay, let's see. We're given that x displacement here is equal to 2.5 sine 0.4 pi t. Okay, now this is looking like the formula we gave, which is a sine A sine omega t, okay, omega t. Now if we compare both, you can see that your A is equal to 2.5, and since all distance is in centimeter, this is centimeter, so A is 2.5. okay, then if you notice here, t here can cancel t here, so omega is what? Omega is 0.4 pi from the question, 0.4 pi. So with this we can answer any question. The first one is we should determine the magnitude of the maximum velocity. So we can say that Vmax here, Vmax here, remember the formula is omega A. So my omega here is already 0.4 pi, 0.4 pi, then multiply by A. My A is 2.5 centimeter. So our answer will be in centimeter. So if we use our calculator, it will say 0.4 times pi, then times 2.5. Pi is 3.14 in case, okay? We're going to get 3.14. So the answer to that question is 3.14 centimeter per second, since the amplitude is in centimeter. So it's going to be centimeter per second, okay? Now let's see, the next one is acceleration. What is the formula for acceleration? Maximum acceleration. A maximum, like we said, is equal to omega squared A. So your omega here will be squared, which is, that means 0.4 pi is going to be squared in this case, squared, then multiplied by your A is 2.5. So if we use our calculator here, your 0.4 pi, it should be squared. 0.4 pi, which is squared, then multiplied by 2.5. Okay, this is giving us 3.95. So we have 3.95, but the unit in this case is going to be centimeter squared, centimeter per second squared, centimeter per second squared, since the amplitude is given in centimeter. I believe this is clear. Now we see the next question. It says the amplitude of a particle executing simple harmonic motion in is 5 centimeter. That's a mistake. While its angular frequency is 10 radians per second. Calculate the magnitude of the maximum acceleration of the particle. This is quite simple. If you notice, the options given here are all in meter per second. So that means I'm going to change the amplitude. The unit 5 centimeter, we are going to convert it, so that will give us 0.05 meters. Okay. Then the angular frequency here, or angular velocity, is 10 radians per second. So here we are asked to find 10 radians per second. Here we are asked to find maximum acceleration. Maximum acceleration, like we know, is equal to omega squared A. So your omega is 10, so that means 10 squared, then times A. Your A is 0.05. So 0.05. Now if we use calculator here, we are going to have 10 squared times 0.05. That's going to give us 5. So the answer is 5 meter per second square. That's the answer. So the answer is D. Okay? This is beautiful. This is beautiful. Now here, we are given, it says, the amplitude of a particle executing simple harmonic motion is, okay, I think we've answered this. Okay? Look at this. It says a simple harmonic oscillator has a period of 0.02 seconds, an amplitude of 0.25 meters. Calculate the speed in meter per second at the center of oscillation. Now, whenever you are asked to calculate speed at the center of oscillation, the same thing as saying calculating the maximum speed, because the speed is maximum at the center of oscillation. So, but we are given period to be 0.02 seconds. So the period t is 0.02 seconds. Now, actually, the reason for the period is so that we can find the angular frequency, because angular frequency is 2 pi all over the period. So that's going to give us 2 times 3.14 divided by your period here is 0.02. So if we divide that, 2 times 3.14 divided by 0.02, that's going to give us 314. So we are going to have 314 radians per second. So with this now, we can now find the velocity, maximum velocity like we say, which is the velocity at the center of oscillation is omega A. So your omega is 314 multiplied by your A, your amplitude is 0.25. So let's do that quickly. Sorry, that's a mistake. 0.25. So 3.14 multiplied by 0.25, we are getting 0.785. So that will give us what? 0.785. 0.785 for, is it 0.785? Sorry, that's going to give us 70. Oh, the answers are in pi. So let's leave our answer in pi. Sorry, we're going to redo the whole of this and leave our answer in pi. And the options, the answers are left in pi. So let's clean this. Sorry for that. Okay, so now let's see. We have 2 pi over period. So this is going to be 2 pi over your period is 0.02, which when we treat 2 divided by 0.02 is going to give us 100. So that's going to be 100 pi, 100 pi. Okay, so since the maximum speed V maximum is equal to omega A, your omega is already 100 pi. Okay, now multiplied by the amplitude is 0.25. So when we do that, we are going to get 25 pi. Okay, so the answer is 25 pi, which is B. This is beautiful. Okay, so we go to the next question. Here it says a body executing simple harmonic motion has an angular speed of 2 pi radians. Its period of oscillation is, we are given pi to be 3.14. So let's do that quickly. Since it has an angular speed, okay, angular speed of 2 pi, angular speed is 2 pi, and we're looking for period. Angular speed is also 2 pi all over period, okay, so which is equal to 2 pi. So that means period is going to give us 2 pi over 2 pi, and that's equal to 1. So 1 second, we'll find that in B. Okay, now this is another question. It says a body executing simple harmonic motion has a speed represented by v equal to 3 root 16 minus y squared. The displacement is in centimeters. Find. Now we are given different things to find here, and so let's see. But we are given to v to be equal to 3 root 16 minus y squared, which actually looks like a formula where speed is omega root a squared minus y squared. So if we compare the both equations, you'll see that your omega here is equal to 3 when you compare both. And you see also that your a squared is equal to 16. Your a squared is 16. Where a squared is where we have 16. Okay, so if a squared is 16, it means that a is equal to square root of 16, which is 4. Beautiful. With this, we can answer any question. So we've answered the first one, which is amplitude. Amplitude A is 4. The second one here is frequency. From the omega, we can find frequency. Since we know that omega is 2 pi times frequency is equal to 3. So that means the frequency is equal to 3 over 2 pi, which when we calculate, that's 3 divided by 2 pi, that means 2 pi, 0.477. So that's giving us 0.477, okay? 0.477. Now the next is we should find the maximum velocity. Now what is maximum velocity? We know that maximum velocity Vmax is equal to omega A. So your omega here is already 3 multiplied by your A is 4. So maximum velocity will give us 12. So that's 12 a meter per second if it is in meters. Okay, beautiful. So let's see what we can do. Let's clean up. So frequency is 0.477. Now let's clean up so that we can answer other questions. Let's clean this up. Okay. Good. So the next question says, we should find the velocity when the displacement is 2 meters. I guess that's quite easy because velocity is already 3 root 16 minus y squared. But the question says the displacement is 2 meters. So we'll say that v now will be equal to square root of 16 minus your y is 2 from the question. The displacement is 2. Since it's in centimeter, the maximum velocity will be in centimeter per second. So 2 squared. That will give me 3 square root of 16 minus 4. That will be 3 square root of 12, 3 root 12. And that will give us 3 times square root of 12 is going to give us 10.39. So 10.39. Here will be centimeter per second since our displacement is given in centimeters. Okay. Now the next is total energy of a system. Now I want you to know that the energy of a system, the total energy of a system, even though we'll still look at that soon, the total energy of a system has a formula. ET is half m omega squared a squared. Please note that half m omega squared a squared. We are not given the mass, so we are going to assume a unit mass, maybe 1 kilogram. So you are going to have, this will be half times the mass m. We are assuming 1 kilogram here is supposed to be given, but is omitted in the question. Then multiplied by the omega is 3, so we have 3 squared. Multiplied by a, your a is 4, so we have 4 squared. So by the time we multiply, that means 3 squared times 4 squared divided by 2 is going to give us 72. So the total energy is 72. Then the next one says we should calculate the potential energy at this displacement. The displacement here is 2 centimeters. Potential energy EP is equal to half m omega squared y squared. That's the formula. Okay, so that will be half times mass. We are using a unit mass 1. The omega here is 3, so 3 squared times y squared. That means in this case now your y is 2, displacement 2 squared, which when we are going to get 18. So this is 72 joules, here is 18 joules. Then the final question says we should find the kinetic energy at a displacement of 2 centimeters. What is kinetic energy? Please note this, that kinetic, the total energy of a system is equal to the potential energy EP plus the kinetic energy EK. So the total energy is 72, the potential energy is 18, plus kinetic energy, which is EK. We can find that means my EK now will be 72 minus 18, and 72 minus 18 is going to give us 54 joules. So 54 joules is the answer to that question. Okay, so that now leads us to energy of a simple harmonic motion, which is what we've seen in the previous question. Now here it says the kinetic energy of a simple harmonic motion, EK, is half mv squared, of course. But remember that your v is omega square root of a squared minus y squared. So if we substitute that, squaring it, we are going to get kinetic energy to be half m omega squared a squared minus y squared. Now the total energy of a simple harmonic motion, like we know, is supposed to be half m v squared, maximum, the maximum velocity. So if we substitute the value for maximum velocity, which is omega a, we'll get half m omega a squared. That's how we came about that formula. Then the potential energy of a simple harmonic motion is total energy minus kinetic energy. Earlier I showed you that total energy is equal to potential energy plus kinetic energy. So when you make that subtraction, you're going to get half m omega squared y squared. That's important. Now look at a question here. It says a body of mass 20 grams performs a simple harmonic motion at a frequency of 5 Hz at a distance of 10 centimeter or displacement from mean position. Its velocity is 200 centimeter per second. You see, given in centimeter. I calculate the maximum displacement from the mean position. Maximum displacement is amplitude. Then II says we should find the maximum velocity. Then III says we should find the potential energy. Okay, but we are given mass to be 20 grams. 20 grams, if we need to convert that, that will be 0.02 kilograms. Okay. Now we also have velocity. We can use this formula that velocity is equal to omega square root of a squared minus y squared. Okay. And your v, the question, velocity is 200, is already given. Equal to omega is not given, but frequency is given. We can say that omega is 2 pi times frequency. Okay, that means 2 pi times your frequency is 5. That will give us 10 pi. Okay, or which if you multiply, you are going to get 31.4 radians per second. Okay, and so this will be 31.4. Now this is square root of amplitude is what we are looking for, so we say a squared. The displacement y is 10 centimeters, so we are going to use 10, so 10 squared. Now if we divide by both sides, 200 divided by 3.14, 200 divided by 31.4, we get 6.37. So we are going to have 6.37, okay, is equal to square root of a squared minus 10 squared. Okay, if I take away the square root, it means I should square 6.37 squared. That will give me 40.58. So 40.58 is equal to a squared minus 10 squared here means 100. If I take minus 100 to the other side of the equation, I'm going to get 140.58. 140.58 is equal to a squared. Okay, that means my a will be square root of 140.58. This is beautiful. 140.58, we're going to get 11.86. So 11.86 for the maximum displacement from the main position. The next question says we should find the maximum velocity. Maximum velocity, like we know, V max is equal to omega A. Okay, so the omega here is already 31.4. Then the A is 11.86. And that will give us, so we have 31.4 times 11.86. That will give us 372.40 or 0.4 centimeter per second, since the distance is given in centimeter. Okay, the last question here says we should find the maximum potential energy. Okay, now please note, maximum potential energy actually means the total energy. It's still the same thing. According to conservation of energy, maximum potential energy is the same thing as maximum kinetic energy, and it is the same thing as potential energy. So since we are asked to find, assuming we are just asked to find the potential energy at a displacement of 10 centimeters, that is what we will use. But here we are asked to find the potential energy at the maximum potential energy. So my maximum is still ET, total energy. That will be half m omega squared a squared. So which means half times m. M is mass. Mass is 0.02. Okay. Times omega. Omega we got to be 31.4 squared. Amplitude. In this case now we need to convert the we got amplitude to be, trying to remember, we got amplitude to be 11.86. Now, but this 11.86 is in centimeters, which of course we need to convert to meters. So that will give us 0.1186. So multiply by 0.1186, and that will give us 0. I'm using my calculator here. So that is 0.037. So we have 0.037 joules. Okay, so that is it for this question. This is beautiful. Now that leads us to the next thing, law of conservation of mechanical energy in simple harmonic motion. Now, according to the law of conservation of mechanical energy, the total energy ET is equal to potential energy EP plus kinetic energy, which means that the sum of the potentials and kinetic energies are constant throughout the motion. Okay, so let's consider a diagram of a simple harmonic motion. Look at this diagram. If you notice, we have 3 points here, point A, point B, point C in the diagram. A there is the maximum displacement when you displace the pendulum. Okay, so Y is maximum, and at maximum displacement velocity is 0. Please note this very well. And since displacement is maximum, potential energy is also maximum, and kinetic energy is 0. At point B, Y is equal to 0. Okay, we have a note here by the side. Let's read the note. At point A, the displacement is maximum, hence the potential energy is maximum. Whenever potential energy is maximum, kinetic energy is 0. Okay, so hence the total energy is the maximum potential energy. You've seen that, because remember that total energy is supposed to be kinetic. Total energy ET is supposed to be kinetic energy EP plus potential energy EK. So, but in this case now, the potential energy is maximum, EP max. Okay, but the kinetic energy is 0. So total energy is also maximum kinetic, maximum potential energy. Now let's look at point B. At point B, the displacement is minimum, hence potential energy is 0. But velocity is maximum. Okay, so anytime displacement is minimum, velocity is maximum, meaning that kinetic energy is maximum. So in that case now, the total energy is the maximum kinetic energy. Now, but at point C, the bulb has a partial potential energy and partial kinetic energy. So hence the total energy will be Ke plus Pe. So the potential energy at that point plus the kinetic energy at that point. From there, we can say that the maximum potential energy, Pe maximum, is the same thing as Ke maximum. But is the same thing as Pe at a particular point plus the Ke at that point. So this is the concept of mechanical conservation of mechanical energy. Now I would like to say this, that that wherever displacement is maximum, your acceleration is also maximum. Whenever displacement is maximum, even acceleration is maximum. So note that. But whenever displacement is 0, acceleration is also equal to 0. Please note that. Thank you very much. We have reached the end of this class. So see you in other courses.